Today we're gonna learn about hexose monophosphate shunt, that is alternative glucose oxidative pathway. Hexose monophosphate shunt ni also known as the pentose phosphate pathway or phosphogluconate pathway. It occurs in the cytoplasm. The function of the hexose monophosphate shunt is to produce NADPH, ribose 5-phosphate, and act as the connection road for glycolysis and citric acid cycle. The production of NADPH is for biosynthesis reaction such as fatty acid synthesis and drug reduction. And for production of ribose 5-phosphate, it's for nucleotide and nucleic acid biosynthesis. The major site for hexose monophosphate shunt is steroidogenic tissue, red blood cell, and liver, while muscle is the minor site. Hexose monophosphate shunt also divided into two phases, that is oxidative phase that generate an ADPH, and also non-oxidative phase that synthesize pentose phosphate and other phosphate monosaccharide. Next, we're gonna learn about hexose monophosphate shunt. First, it starts with the oxidative phase. From the oxidative phase, glucose 6-phosphate will convert into the 6-phosphogluconolactone by the presence of glucose 6-phosphodehydrogenase. In this process, 2 molecules of NADP+ will convert into NADPH. Then 6-phosphogluconolactone will convert into 6-phosphogluconate by the presence of the gluconolactose, and water molecule will convert into hydrogen ions. The last step for oxidative phase is 6-phosphogluconate will convert into ribulose 5-phosphate by 6-phosphogluconate dehydrogenase. In this process, NADP+ will convert into NADPH and carbon dioxide will produce. To make it more clear, you can see this pentose phosphate pathway. Next, from the ribulose 5-phosphate, the non-oxidative phase start. Non-oxidative initiate when the cell need more NADPH than ribulose 5-phosphate. The reaction led the changes of C3, C4, C5, C6, and C7 pentose sugar to form. These changes is needed to form glyceraldehyde 3-phosphate and fructose 6-phosphate, which can go directly to the glycolysis. The ribulose 5-phosphate is converted into ribose 5-phosphate by the presence of the phosphopentose isomerase. The ribose 5-phosphate is the isomerism to the ribulose 5-phosphate. The ribulose 5-phosphate then converted into the ribose 5-phosphate by the presence of the phosphopentose isomerase. The ribulose 5-phosphate is the isomerism to the ribose 5-phosphate. The ribulose 5-phosphate also can converted into cellulose 5-phosphate by the presence of the phosphopentose epimerase. These two reactions is reversible. When the ribose 5-phosphate is react with the cellulose 5-phosphate, it gives glyceraldehyde 3-phosphate and pseudoheptulose 3-phosphate. Simply this is a 2-carbon shifting mechanism. The ribose 5-phosphate, when it reacts with the cellulose 5-phosphate, it will converted into glyceraldehyde 3-phosphate and pseudoheptulose 3-phosphate in the presence of the transcriptase to form the product. Simply, this is a 2-carbon shifting mechanism. When glyceraldehyde 3-phosphate react with the pseudoheptulose 3-phosphate, it will converted into fructose 6-phosphate and erythrose 4-phosphate in the presence of the trans-aldolase. Simply, this reaction as a 3-carbon shifting mechanism. So it already got the product for the pen. So it already got the product where glyceraldehyde 3-phosphate and fructose 6-phosphate is produced. These two the glyceraldehyde 3-phosphate and the fructose 6-phosphate can go directly to the glycolysis process. As we show you, this is the pathway for non-oxidative phase. This one is start with the ribulose 5-phosphate and converted into 5-phosphate, and the product is produced. Okay. And the next one is the second converted, where ribulose 5-phosphate is converted into cellulose 5-phosphate. So this is the pathway.